right. Let Twitch get warmed up here. So make a few changes. Oh, chat says there's no sound. Is there sound now? Hang on. I'll have to redo all that and edit it at the end. All right, excellent. Let's back it up. Back it up. Okay, since we were going with no sound, so Storybox. Storybox is a bit of interactive fiction, and it allows us to load various games via this interface. So that's what it is. And there's a brainstorming document here that kind of tells you what interactive fiction is and gives you some examples. But more importantly than being an interactive fiction engine, is that Storybox is a guide and an example project for our syllabus-y kind of class structure thing. And what we're hoping to do is to introduce design patterns in this kind of logical way that gives you a complete thought, right? A way to approach application development that keeps your code clean and maintainable. So we tried that at first with the MUDZ game, and it kind of came off the rails. So we're going to keep finding these example projects and keep trying until we get down a nice, clean-ish approach to approaching applications. So in our first semester, we went over factory pattern interpreter, context object, state pattern, chain of responsibility, and facade, which got us so far. And now we're going to start diving into not necessarily the more advanced patterns, but certainly patterns that really only show their merit later on in the application's life cycle. So that brings us to the actual application. If you go to GitHub and you pull down the code, you'll see 4 projects, and they're broken up what I hope to be logically. I definitely recommend, if you aren't familiar with the project, to go back and watch the videos and see the method to all this madness. But in the end, we're able to refactor our code down to something that looks pretty clean. Starting on the outside, I've got an app context. That's going to be my facade. This is my facade for the rest of my modules. And it allows me to have a pretty clean API to anything that wants to consume this. So when I type app dot, I'm only seeing start and stop. I'm only seeing the things that I choose to expose. Dan G says, how have you been? Missed last couple of streams. Then you were on break. I've been good. How have you been? Yeah, it was a longer break than I thought, and I'm on a new day and a new time. Because I wasn't feeling very well yesterday, and I'm still not really feeling great. And I'm also trying to figure out where watching people code in the live stream thing is going, and where I fit in it. But so far, so good. And there might be some more time changes, but I can at least promise that the videos will always be available, and you can always come back and watch them, even if you don't come in and participate. So, app context is a facade. Good declaration. And so we come back over here, and I'll just do this and this. So, this is our facade that we covered on our last stream that allows us to hide some of the underpinnings. And then we have our chain of responsibility, and that really came into play within our game context object. So that was all the way back to week 3 was our game context object. So I go into this guy. So our facade has encapsulated and hidden this game context. Going to that guy, I start seeing the meat of all of our previous streams. I see a state pattern, and I see these game handlers, which is our chain of responsibility. So, why this is good is that we've got a facade now, and we've got a game context. So instead of having to think about our code as this big sprawling mass that's just getting bigger and bigger and bigger, we only have to think about it in terms of 2 modules. Our application, and then our game context. And so every time we add on, moving forward, we're going to be adding new context. So you might have like an authorization context. You might have, a messaging context, right? To handle notification between players. So all these things are going to be their own modules, and they're going to be well isolated from the rest of our code, so that each module or each context has the freedom to grow independently. And then we're going to hide all that. We're going to stuff it all behind our app, our application context, which is our facade. So, and all our facade does is call game start. And then all game start does is sets the app state, this is being the state pattern, to running, and then goes to the game context, because we only have one, and starts that. So when we play the game, or load the engine, as it were, what this is doing is it's coming in to game start, and then it's going into the game context. So I'll run through it once, and then I'll debug it. So I put my name in, it sees who I am, so now it knows who I am. I choose my game, it now knows what game I want to play. Presumably it's also loaded the game in that step, right? That's part of the chain of responsibility. And now it wants me to input a command for this newly loaded game. And it'll crash here because we never really got to how commands would be translated to the game. That's where our command pattern comes in. So we'll see how far we can get with that, because we definitely want to get the command structure set, and then we should be able to start working on some actual game mechanics, like how do you load a game, what does a game look like, and how are those commands interpreted. So let's come back over to our, and we'll just do C# command pattern. Hang on, I'm going to turn on a fan. And if you can hear this fan and it gets distracting, let me know. This is going to be our test. Alright, so the definition of the command pattern is encapsulate a request as an object, thereby letting you parameterize clients with different requests, queue or log requests, and support undoable operations. So this is more or less what we want. And let's go ahead and debug and see where it might be able to help us. Let's go ahead and hop in here to game start. Alright, so game start sets the app state as running and starts the context. Alright, so we should back that up. Yeah, let's back that up a little bit because there's some fun stuff in there we really want to take a look at. So when we come in here, let's go ahead and F11 into that start function. And now we're inside of our game context. And we're going to start moving through our chain of responsibility. So I hit F10 to come down to the next line, and I'm looking at game handler.process. Now, inside of the game context, I set the game state for this context as load player state. And then I set the game handler as player load handler. And then I set the successors. And if you have any questions about that, definitely recommend going back and watch the chain of responsibility. But it really lets us to, now that we're in the context, now the context has a world of its own, right? Its own architecture. And again, this allows our game context to grow in whatever ways makes sense to it, without having to spill over architecture or ideas or dependencies or coupling to the rest of our application. So, we get game handler.process. And the first thing you should notice is that we're now inside of an abstract class. So the abstract class allows us to have some base functionality that all implementing classes or inheriting classes are going to have by default. So whenever we debug, we're going to come here, because this is where that code and that logic lives. So we come down, and this allows us to set a very rigid structure for how we want our chain of responsibility to operate. So every time something comes into our game context and is processed, it's going to follow these steps: load state, display prompt, read line, interpret, display response, unload state, and then move on its successor to be processed. So when I load the state, and we talked a bit about the state pattern before, in that this load state could be really expensive. So we don't want to do it if we don't necessarily have to. And that should be taken care of inside of that load state method. It should check and say, if I don't need to load, go ahead and just move on with your life. And I display the prompt, and then I read line. So all this logic, right? All this logic is being implemented by our player load handler, but we're seeing the flow of it here. So I type in Gary, and then come into interpret. So let's go ahead and F11 into one of these for the first time. So now I'm in the load player state, the concrete implementation of this game state. And its sole job is to set the current game state and then do interpret. Ooh. And this is our interpreter pattern. Our interpreter pattern is right now very tightly coupled to the state, but it's what allows us to change the personality of these states depending on what interpretations we need. Come through. We've already displayed the response of welcome Gary. And now we're on to the next handler. The next handler, I believe, is the game load handler. So very same thing. I don't want to spend a lot of time going over what we've already covered in the previous streams, but I am pretty happy with how far we got in 6 weeks. I think it really shows how 6 design patterns used together can give you a pretty elegant and pretty sophisticated architecture. So, where does that leave us? Well, we want a way to, let's go over to our game handler. So user input. User input is great, but it's not a command, right? It doesn't really tell us anything. It doesn't really safeguard against bad inputs. It doesn't really structure the request in a way that like gleans anything. It's just a string of characters. So we can definitely improve on that. And this is where we want to inject our command pattern. We want to be able to say, hey, whatever user input comes in is translated into a structured command. And then that command is passed forward for interpretation. Now, since this is a text-based application, the command's ultimately also going to be in text. But we can cheat based on what we know so far from the application. We know what state it's in, right? And we know what handler it's using. So based off those two things, we should also be able to derive or set enough information about the command so that we can make further interpretations instead of our interpreter. Further interpretations instead of our interpreter. Yeah, I think that works. And right now we can't do that because we just got a lot of text. So let's go back over to the definition of the command pattern. Encapsulate a request as an object. We definitely want to do that. Thereby letting you parameterize clients with different requests. I definitely like that. It's going to come to a point where we have multiple contexts, right? We've got that, authorization context, we've got that messaging context, we've got that game context. We've got a lot of things that could be receiving this command. And we want to make sure it's going to the right place. So right now our game context really should only be getting commands related to the game. If it got a command that was a messaging command, it should know before doing anything, I don't have anything to do with this. Dump back out and throw an error. And you can't do that unless you have some sort of context. Okay. So what does the command pattern consist of? Well, the UML diagram, like all these things, is really simple. Deceptively simple. So we've got a client or a context. In this case, more than likely going to be our game context. We have an invoker. So the invoker is going to be technically our app context, but let's just call it our calling layer. So our app context is going to be invoking these requests. It's going to take it, it's going to say, hey, I need you to do something with this. I'm just a middleman. I'm just a false front. You handle it. Then we have a receiver. So, I think, and this might change, but I think our receiver is going to be the interpreter. I think, right? I think this is going to be what interprets the request that comes in. So we've got a receiver. And then we have our concrete command. So, nothing crazy, but we're going to try to strap this thing on. Let's close out some stuff and come right back to the program class. Whoops. So, I come into app context. Now, we'll notice when this should be the theme of our next stream, that we don't have a way to decide what context to load. Now, it doesn't really matter because we only have one context, but I've got a sneaking suspicion that in the near future, we're going to have more than one context. We're going to want to know a way to intelligently, based off probably the app state, to know which context to send commands to. Okay, so what does our client look like? Scroll down a little bit. I'll show you some things I like and I don't like about the a lot of the design pattern or the command pattern explanations that are out there. Right here, where they encapsulate the receiver inside of the command. So, what that would look like for us is that'd be like if we decide that our interpreter is the receiver, that would mean that every interpreter would also have a copy of the game context. It'd be weird. Things would be nestled really weirdly. So I don't necessarily like that. But let's start with common. And I know that I do want a command. Let's start with an interface. I might move this here in a second. So, their command looks pretty simple. It's got a constructor, it sets the receiver, and it's got execute. Well, I kind of do want execute until we decide we want to change. That's really all I want. Okay. And let me read app context. Let's jump into our game context. So, is there anything inside of our game context that we can encapsulate? We don't encapsulate the entire game context. But is there anything that might be able to pass along that'd be helpful in interpreting the command? Well, I think game state would be good. There's the game state type. Load player game selector playing. I think that's good. Let's just go with the type. Alright, so inside of our command, we know what the current game state is. We've got something that's going to execute. And what else do we need? User input. User input would definitely be good. Something too crazy, just 3 things. Anything else? We started a little bit last time by doing a command type. This is good. So inside of our game, we've got certain commands. And then inside of our other contexts, right? So this only applies to the game context. Inside of our other context, we're going to have different commands. So this is really important because if a command goes into the wrong context, it's going to fail. So we do want a command type. We want it to be more generic than just this enum. But for the time being, I think that's fine. So this is really all we need. And this way we aren't passing around the entire context. We aren't encapsulating the entire context. Instead, we're just taking a a very light object that represents the command that's coming in, and we can do what we want with it. Okay, so I've got a command. We already know what our invoker is. Or we actually have multiple candidates for the invoker. We know what our receiver is. We definitely know what our receiver is. So we want our interpreter, which generates an expression, to also be the receiver. So, what does that mean? So all the receiver has to do is have an action. And again, I'm trying to stay truer to these outlines, but they really do kind of leave you hanging, right? So I'm really using this as a reference to make sure that we get all the vocabulary, be consistent. But when we say execute, in our lingo, we're going to be talking about interpret. So we already have this part of the architecture within our application. There's no need to repeat it. I think this is one of the best points about doing these streams, where we're bringing all these different pieces of architecture together. Unfortunately, being able to show the interoperability of these patterns is kind of beyond most tutorials. So we get here and we need to, we need to really crunch for a second. We need to say, this is my receiver. The interpreter is my receiver. And to execute is what we've already called interpret. So there's actually no reason to come in here and say, okay, well then I need a public abstract void execute that takes in something, right? We don't need any of that. All we need is our interpret command, and that'll satisfy presumably this entire abstract class. And our interpreter already is an abstract class. And the only thing that we're doing differently is we're not encapsulating our game context as part of our command. What we can do, though, is this. We can say public expression takes in an I game context, and once we make this protected, we probably will in a second. But, and then inside of here, we can use the current game context for this interpreter to create our command, as opposed to just assigning it, right? So we're doing something different in our constructor here, because we're saying, hey, we don't ever want this to be a part of the command. And I'm sorry, before I said execute, I meant action. Interpret becomes our sole action. Okay, so, and we've still got this guy over here, which we do have execute on. Boom, boom, boom. Okay, so we already have an interface, which is the beauty of interfaces, is that we can kind of test out what we have so far. So back inside of my, let's go ahead and close this, my expression, I have a game context, and I want to interpret. So I can say, well, I have a command object, And I can say that command is equal to new. Well, you actually have something here to new up, unfortunately. If I was to say new I command, I need to put a constraint on that interface that say it can only ever be a class. We could do that. Or we could just start up a new abstract command. Let's do the abstract command. Because again, we're going to want different commands for different contexts. So right now this feels okay. So, presumably what this allows us to do, let's just walk through this after I cheat a bit. Okay, so what this is going to allow us to do, just to back it up for a second, is we want to be able to use the same architecture between multiple contexts, which means we need to be context agnostic. So by having a interface and by having this abstract class, we can code against that contract and then allow every context to create their own concrete implementations. Okay. Just going to clean this up a bit. Execute. We still want to keep this for the time being because we haven't justified a reason to take it out yet. We justified a reason with our receiver to collapse it into what we already have in our interpreter, but we haven't justified moving execute yet. Let's make that abstract. Okay. So far, so good. Oh, hang on. Okay, sorry about that. Messages coming in from all sides. Alright, so we got a command, or the beginnings of a command. We are not pulling in the receiver. We're keeping execute. And we're also giving it a few properties we think we're going to need. We have our receiver and the interpreter. We have our invoker and the facade. So again, we've collapsed that invoker and we said we already have an invoker. The invoker is always going to be our facade, our app context. So I think we're good here. Let's look at, within 9 minutes we've got left, let's look at how this new pattern is going to fit in and cause us to refactor a little bit. So commit to app context, go to declaration. I'm now inside of here. I don't know what kind of I don't know how to switch context yet. That's a problem for another date. So I just go ahead and start with the only one I know, which is the game context. And then inside the game context, I hit start. And this is going to start processing. So let's look at our handlers. Trying to figure out a good place to start stuffing this command stuff, but we'll get to it. Alright. So, into my handler, all I do is handle the request. And inside of my abstract class for game handler, this is the line that I kind of want to remove. So I like the idea of having a game context, game context, game context that's going to populate all the things I need here. Game state type, game command type, user input. So what if I'm not going to new up an abstract class, just so we can see how this might fit in. Let's not make this abstract. Let's say if we came over here to our game handler and I said var command is equal to new command, and I said command.userInput is equal to console.readline. And then I got rid of the game context user input. So that's gone. So coming over to game context, it's a pretty good safe bet that no context should have a direct line into the user input now that we have a command. Okay. So we still need to have some way for the command itself to know what it's trying to do, right? But we can set the game context current command to whatever we're doing. So in here, to do stuff with command. Then we can say game context dot current command. Oops, hang on. Come over to the game context. We've got game context command type here, but it's not part of our iGame context. So let's remove the user input. We'll put that there for now. Okay, so we can say game context dot current command is equal to command dot command type. So we said before in terms of the context object that the context object should have some idea of what it is and what it's currently doing. So if you were to crash or something were to fail, you should be able to look at each part of your application and be able to discern where it was when the crash happened. Or if it exits early, you should be able to tell what state it was in when it exited, when it finished, when it aborted, whatever have you. This is what this allows us to do. We're keeping the game context kind of, you know, in the loop in terms of what we're doing inside of our different pieces and parts. It's kind of functional. It's got some functional programming principles to it. All right, so. And then our idea is that from this point forward, right, like we said, we've got a receiver. We've got a receiver in our interpreter. So what we want to do is we want to change our interpreter so that it now receives this command. And then ideally, for the rest of this, for these next two, we might also be passing the command in. But definitely right now for our interpreter, we want to switch this around a little bit. Let's make it over an expression. And remember, and we don't even need that. This was a red herring. So our interpreter takes in the game context. Before we do anything, let's look at inside one of our interpreters, all of them actually, and make sure that we're not unwinding anything we really need to, that we don't really need to. So, let's go into core, game, handler, not a lot. Okay, so instead of our handler for our player load, all we're doing is saying, hey, if the game context, that player, is not null or empty, set the game state to game selection. Okay, that's fine. Okay, we're saying game state, and we're saying game state so far. So this is great. So far all we're doing is setting game state each one of our handlers. Now, let's look at the actual game state objects. Hang on. I'm going to close all but this. So, looking at our player, our game states, which have our display prompt, our interpret, and our display response. So this is what we want to change. So we've looked at our actual human responsibility objects, and we've said all they're doing right now is they're setting the state. So they're kind of off to the side. Let's look inside the actual state objects that got set by the handler, and we see our interpret. And we also see that our interpreter is being called directly. This is all good stuff. So we are setting game state here. So let's say that it's not the responsibility of the interpreter to set the game state. I think that's fair, right? Probably more than fair. So there's a better place to put anything having to do with managing the state. So we don't want to crowd up our methods with doing more than one thing, because then we're breaking the single responsibility principle, right? So if you said, hey, what does your interpreter do? Well, it sets the game state and it interprets. Okay, now you're doing two things. So wherever this thing goes, it can't be here. We all accept that was wrong. And that frees, by removing that dependency, that frees us up to say, hey, interpreter, you're taking in an I command of type command. And then we'll pass that command into our interpreter. So right now everything expects to get a context, so let's just dive a little bit deeper. Let's go into our player interpreter. Oh. So, if we change this to I command, ooh, we might need the context. Let's break some stuff first. This is actually, we're by doing this pattern, we're actually seeing some things that we were cheating with before. Let's pick our right expression. And we'll say, you will now only take I command. Oh. Nick Narian in chat, hello. He asks, do you have a YouTube channel with previous live streams? I do. And I think they're down. So, I do have a channel, and they're usually, it's better to go by the wiki. So if you come back over here, my GitHub is in the channel, and we're working with Storybox. So if you came to my GitHub, clicked on Storybox, and then you went to Wiki, and then in this case, first semester, this is going to take you to all the relevant links, including my YouTube. So this is Storybox Week 1, for example. And then once you're in here, you'll have access to, you know, who knows how many other videos that we've done in the stream. So, there you go. You can search for Airy Ugu on YouTube and see what you come up with, or I would recommend going through the wiki to get to all the old information. Okay, so let's go back to breaking stuff. Alright, so we've already accepted in one place that we don't want to break the single responsibility principle. It's really important to us. And then once we're here, we've got a command. Now, the question is, do we want to have access to the context here? Because the context has the player, but you can see how this was weird before. We were saying the player to the user input. It's kind of A equals A in this case. So we don't want to change that. Let's think this through. I like this. We're interpreting the command, because again, the interpreter is our receiver, and this is what has our action. Now, if we go back over to this guy, we do start to see some merit in having, maybe not the receiver, but some encapsulation. So if we had the game context encapsulated within our command, we'd have access to it now. And we could do something really simple. So let's err on, because we're out of time, let's err on this stuff being right, and that we've now seen the wisdom of it. Go back to our command, right, to I command. And since we're now going to be passing in the game context, well, the game context already knows the game state. We're going to leave the command type. Come back over to command, which is our implementation. And we're going to say public game context. And go to the game state because the context already has that. So, that gets us back to here, where we can say command dot game context dot player is equal to command dot user input. Still not great, right? Still not wonderful. So we're missing something. Let's go ahead and fix a few moving pieces, and we'll get back to that. Just coming back through. So we got our game state. And so we're also seeing inside of our game state, we're taking advantage of the interpreter, but we're also doing more things than we probably should. Right? So we're already doing 3 things here. This is worse than the 2 things we were doing before. So all I'm doing is my command. So let's modify our flow and stop if we're jumping around too much. So we come back over to our game handler. We've got load state, display prompt. We've got a command. We're setting a command type. We've got an interpret that command. Game context dot game state. Once we've interpreted the command, once we've got like a good solid command to work with, what do we want to do next? I'm always a big fan of process. I'm going to go to game state. So now I want everything to be able to process. And I'm going to give it an iGame context. So this at least gives us a place to do one of the things we were overloading our interpreter for. So we come back over to load player state. Let's see. I was doing two things here. And then game selection state, I'm doing three things. So I want to break that up into public override, void, process. And now I'm going to do this here. I'm going to have one more. Public override. I haven't written it yet, so I'm kind of going in the future. Void set state. Game context. Context. I'm going to do this one here. And then I'm safe here to interpret my command. So, come back over to our game state. Load state, blah, 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 blah. Already had load state. Let's just use that. But let's just make it abstract, so we have to use it. Clean, clean, clean. So much code. Okay. Load state. We were geniuses in the past. We saw all of this coming. All right. So now I've been able to refactor things, right? Introducing this command pattern has forced me to look at my code and say, if there's a place where I'm doing more than one thing, let me go ahead and fix that, right? Let me go ahead and make sure everything's only doing one thing. And that forces us to evaluate our game handler and really evaluate, oh, hang on, the flow of our application. So we've added a few steps to accommodate this good architecture. So now we're saying that, that I'm going to load the state, which was doing nothing before. Now it is doing something, right? So anywhere I go, I should be able to say, well, load state's now actually doing something. And let's go ahead and fix this guy, which is our load player state. Yep, hang on. I controlled Z back to get this guy. Let's zoom forward. And now I am doing something here. In terms of process, I've got nothing, right? So now process becomes the virtual. Ooh. Neat. Before load was the virtual because we didn't need it. Now we do need it, but when we don't necessarily need is process. And that could change in the future. And when it does, we'll reevaluate and we'll learn our lessons all over again. But for right now, in handler, oops, game state, let's make this one virtual. And we got to give it a body. Empty on purpose. Should remember that in the future. We also have unload state here because past us was super smart. Okay, so because that's virtual, we don't have to implement it. All right. So, can we, now that we have this tool, we have this way to look at our code, can we look at anything else and say, what is it doing incorrectly? Oops. Command. Let's implement those missing members. So game command state, we could say context.gameState is equal to, we could do whatever we want here. But I think command we should leave throwing exceptions because we aren't quite ready to deal with any of the engine stuff yet. Does it look good? Feels good. So, I'm looking at my methods. Everything's doing one thing and one thing only. Displays are displaying. Loads are loading. Interpreters are interpreting. Looks good. Displaying, loading, interpreting. This one I am processing. This is good. So I'm actually processing as part of my flow. Same thing here. So this is all much cleaner. By implementing this architecture, we've been able to scrub our code and make it better, right? We're abiding by the solid principles a little closer. We're less wrong, right? That's one of the key things, is be less wrong. And we've got a fun thing to kind of wedge in. So I'm going to leave you guys here. I'll probably do a little bit of after hours, and we'll recap next week. But what this is allowing us to do is have a firm way to send commands into the system. So next week might be command pattern part 2, where we can wrap all this up before we move into any of the heavier, I say heavier, but we definitely want to go slow. The theme of this project is go slow and really analyze and really make sure that everything's really clean. We don't want to gloss over anything. Like, this is a great refactor and a great catch. I think it feels a lot better. Let's take our time. Also gives the newcomers a chance to catch up, maybe watch some of the older videos, come back with questions. So all the more reason for us to breathe, right? Yeah. Rest on our choices, come back with a clear head, and employ some slow thinking. So, let's see what doesn't build. Ah, yes. So I've got these interpreters. So I'll give you a quick hint of the things I'm going to be changing. Right? So I'm interpreting this as a game library, but I'm setting it here, which is really supposed to be a, what do we say? Oh, a process step. So this is a process step. So what we really want to do is to create this command in a way that it can interpret and look at our user input and then pass that forward. So we'll give some thought to that, and then we'll come back next week and really polish it up, and then we'll close off the command pattern. Because there's definitely a lot to do here, and I don't want to gloss over any of it. Alright, so that's it. Thanks everybody for hanging out. Thanks to Dan G as usual. I think we got a spammer in chat. And thanks Nick for checking us out, and anybody else that was lurking. And I'll see you guys next week.